This is kind of a little bit out of order, but it makes more sense. I had to cover that ground first. Okay, so here's really where we begin. Okay, intro to logs. First, the equation. It comes from here. Y equals to log b to the x. Okay, b is still the base. Okay, just like exponentials, b is the base. So it can be 2, 1/2, 5, whatever. Okay, any number can go there. One restriction that we do have with logs is inside of those parentheses. You can't have a negative number or a 0. Okay, so it's something unique for this. You can't do that. If you did it on a calculator, you would get an error if you did that. Okay, some other unique stuff. If we have the log of x like this, and we don't put a base, so you see how there's no base right there? We in the math world, we know that this is a log x with the base. Anybody happen to know?
It's 10.
It's 10, yeah. It's not as intuitive. There's a reason why it's 10. But we don't need to get into that right now. Okay, so just remember, if it no base, it's 10. You would think it's 1, right? Because like all the other stuff is 1, but it's not 1, it's 10. It's the way logarithm work. There's another one. If you have the log e of x. I feel like with logs, especially after Thanksgiving break, it's just a bunch of rules, just learning all the different rules. So you guys remember E is approximately what? 2.01. So just think of that. And again, it's beyond the scope of the course, but if you ever have free time, just Google Euler's number, which is E, and you can see how it appears in nature and economics and different in the space. It's a real number that appears naturally, and so that's why they call it natural. So it's so special that if that's the base, we call this ln. It has like its own button. It has its own button on the calculator, separate from log. Okay. This is called a natural Again, why natural? Because it appears naturally in nature, like I said, economics, space, and so that's why we call it natural. Okay, natural log. Everybody good so far? Good. Transformations are super easy with these again, so let's do this. Y equals log base b of x. So there's your regular one, right? Without all the movements. So same movements as before. Okay. This is the A. A goes in the front, just like before. A is your vertical stretch and compress, depending on the size. The negative in the front is still your reflection on the X. Your same exact thing as before. And then over here you still have your plus or minus H, just like before. So right goes, negative goes right, and then positive goes left, just like before. And then the K plus K, K still goes up and down, positive, negative. So all the same stuff, all the same stuff. Okay, so pretty easy, right? Okay, now we get to the important part here. I want to do the graphs. Okay, so part 2, graphs. More specifically, I want to do exponential versus logs. If you know one, you know the other, because they're opposites of each other. Okay. So here we go. Both of them are controlled by the B. B for boss. They control both of them. Okay. b greater than 1. So with exponential, we say growth, but with logs, we don't really say growth. We just say increase. So let's use the word increase. Increase. So it's going to go up. Okay. The other scenario is between 0 and 1. Okay. So again, that includes your decimals, your fractions, and the opposite. So instead of increasing, you will decrease. Okay. Okay. So first, let's do exponential. Which you guys already know, okay? But it's just helpful to see them together. So exponential is what you've been working on the last 3 days, okay? So remember, I try to give you little hints, keywords, ways to remember this stuff, right? When you don't have this calculator. So remember exponential growth, think of COVID. A few cases, and then millions and millions of cases. It explodes, okay? So just remember COVID with that one. And it'll help you remember how it grows, okay? These have, and this is important today especially, these have a HA. Which those of you that, what is HA is y equals, remember what's the letter that it equals? It's a K. It's a K value. Okay. Whatever the K is, the up, down, right? Okay, and then decrease or decay is the opposite. You start with millions and billions and then you go down. It's the opposite of COVID, right? And so, again, you have your HA. You want to know something interesting? I don't know if I should put this on the video, but this is pretty interesting. The COVID had a really high R value. R value means like how contagious it is. That's why like it was spread so fast. It was super contagious. I remember when we first got it, we were in a gathering at church. And we have a picture. We didn't know they had it, but we had a picture. And then like it was like 15 people, like 9, 10 of those were sick within days. Like everybody just got it real quick. But anyways, the mortality rate was actually really low. Okay, I mean, people did die, don't get me wrong, but just percentage-wise, it was very low. And there's numbers you can look up. But for example, I think it's Ebola. Those have a mortality rate of like 100%. Like if you get it, you're gonna die for sure. So they said like a super virus that had the spread contagion of COVID, but with the mortality rate of Ebola, it would like wipe out the earth like super quick because they're both super high. But we've never, I guess like the Black Death and stuff have had those. Anyway, I thought it was interesting. Okay, this, now let's do logarithm. Logs. Logarithmic functions. Okay. So what do these look like? Okay, so they're the opposite, inverse. That's why I did inverse a little bit ago with you. So think about how this would look if you were to fold it on that line. Okay, but there's some help too. So instead of having an HA, it's the opposite. It's going to have a VA. And so this is a y equals to k because it touches the y-axis, right? Like if you move it down, it only touches the y-axis. So what do you think the VA equation is going to be? Not y equals, but x, right? Because if I scoot it over, it's just x. So x equals h. Well, that's a big deal, okay? I didn't introduce that like right, but it's the x. So it's just a big deal right here. Is the h. The h tells you the value of your asymptote. So here we go. Okay, so again, oops, sorry, VA. Okay, now here's some hints, okay? We said it has to increase. If b is greater than 1, it has to increase. So how could we draw? I haven't shown you, hopefully you haven't seen on your calculator, but think about how could I draw increasing graph that can't touch the wall. Okay, so just try to visualize one. Or try to visualize this, like if you were to fold it like that. Okay. So it is kind of like COVID, but not on the x-axis, on the y-axis. So a little bit, little bit, little bit, little bit, little bit, a lot. Okay. That's that shape. Okay. I'll fold it for you in a little bit. That way you know how to come up with it. Okay. And this one's backwards. So increasing, decreasing. If you look at them all together, let me see if I could zoom out. This is what I think is confusing. They look very similar. Yeah, they look very similar. It's not like you're doing the U and then the cubic, which are completely different. These look very similar, so that's why I try to give you hints on how to remember what they look like. Okay? Okay, guys, makes sense? Everybody good? Okay. Let's see. I think that's it. I think we can start doing examples. So I'm going to separate the examples.